Hello everyone, I'm Anusha. I'm working as science teacher at MTB JJV School, Bangalore. I have 3 years of experience at MTB School and other various institutes. I have completed my MSc and B.Ed. I have pursued my B.Ed also. Today I am going to explain structure of atom, which is the 4th lesson of class 9. Okay, let's begin with the topic, structure of atom. So, atom. About atom, we have learned something in the third lesson, atoms and molecules. In the previous lesson itself, we have studied some things about atom. Okay, see about atom. What is the basic thing about atom? Atom is a fundamental particle of all the matter. Okay, see, all the matter is made up of the smallest and indivisible particle known as atom. Okay, see, regarding atom, Dalton has given some theories, some postulates about the atoms. Okay, according to Dalton, atom is indivisible, smallest and indivisible. Atom cannot be divided further. Okay, and also atoms of same element for same characteristics. Okay, for example, take example of sodium. Okay, sodium is an element. All the atoms of sodium possess same characteristics. Okay, see, 50 atoms of sodium will possess one character. 50 atoms of sodium will possess another character. It's not like that. All the atoms of a same element possess same characteristics, and atoms of different elements. Okay, for example, magnesium. Magnesium is a different element. Atoms of different elements possess different characteristics. Okay, magnesium atom possesses different characteristics than sodium atom. Okay, and also he told that atoms of different elements. Okay, atoms of different elements combine in a definite proportion in order to make compounds. Example, NaCl. NaCl is a compound. Okay, what's the ratio? 1:1. Okay, one sodium atom combined with one chlorine atom in order to form sodium chloride. If it is like this, see, this is a definite proportion. 1:1 is a definite proportion that will not change at all. If it is NaCl2, then it is not called as a sodium chloride. Okay, because the proportionality has not maintained. Understood? See, these are some postulates explained by the Dalton. And also, see, when Dalton has given the atomic theory, he did not explain about the structure of atom. Okay, for anything, in order to prove that, he should show the structure of atom also, but he did not give proper structure of atom. Okay, so it leads to other scientists to discover the structure of atom, and they were very eager to find whether atom is divisible or it has contained subatomic particles. Okay, that leads to many discoveries. Okay, and also one more thing, like electrostatic force. Okay, see, electrostatic force also leads to discovery of subatomic particles. See, what is meant by electrostatic force? We have done so many activities in your lower classes based on this electrostatic force, because it seems a bit interesting, isn't it? If you rub aluminium foil or a PVC pipe against a silver cloth or woolen cloth, if you bring it near a balloon or any soft light particles, they will get attracted to that charged PVC pipe or aluminium rod. Okay, and also simple experiment, if you comb your hair, okay, if you bring that comb near the paper particles or thermocol balls, they will get attracted to that comb. Okay, why? See, we have seen only magnet and magnetic particles will get attracted. Why these comb and paper particle, PVC pipe and other aluminium foils, why they are getting attracted? See, only charged particles will attract. Why these particles are why these substance objects are converting into charged particles? What making them to convert into charged particles? See, all the particle, all the substances, all the objects are made up of atoms. If atoms get charged, then that substance will act as charged body. Okay, what making them there? Why that atoms are converting into charged particles? This leads to think that whether the atom contain its subatomic particles. Okay, so in 1900, J.J. Thomson J.J. Thomson discovered electrons, okay, by using glass discharge tube, by conducting experiment through in the glass discharge tube. This is a glass discharge tube, negative, positive. Negative end is known as cathode. Positive end is known as anode. Okay, see this vacuum. It contains vacuum. Okay, and this discharge tube is filled with the gas. Okay, this discharge tube is filled with the gas, any gas. It may be hydrogen, it may be any other any gases. Okay, see, Faraday has explained that gases, okay, gases will conduct electric current under high voltage and low pressure. Okay, if you put them under high voltage and low pressure, they will conduct electricity. Gases will conduct electricity. This was explained by Faraday. Okay, same thing J.J. Thomson has implemented in his experiment. He has filled the glass discharge tube with the gas, okay, and he has connected electrodes. Okay, this tube is a sealed glass discharge tube. Okay, and two ends are connected to a battery. Okay, battery. Why we are using battery? In order to provide high voltage. Okay, and this glass discharge tube contains vacuum. Okay, in order to adjust the pressure. Okay, so first he did experiment with 10,000 volts. He passes 10,000 volts at 1 atm, 1 atmospheric pressure. Okay, under that condition, he will not observe anything, or he will not observe any changes. Okay, and later on he will keep on decreasing the pressure. So at low pressure, what happens? He will observe some radiations on the anode side. Okay, see, in order to make observations, he has used fluorescent screen. Okay, fluorescent zinc sulfide screen beside the anode. He has used zinc sulfide screen. Okay, see, he observed that some particles are moving from cathode to anode. Okay, here some particles have started moving from cathode to anode. Cathode is negatively charged terminal. Anode is positively charged terminal. Okay, so how he got to know that the radiation is passing from cathode to anode? See, he has a fluorescent zinc sulfide screen. Upon that screen, when these particles hit the screen will glow green. Okay, because of that, he will observe that okay, some particles are moving from the cathode to anode. Okay, see, if anything is getting attracted to the positive charge, means that charges are negative. Okay, see, only negative charges will get attracted towards the positive. Okay, see here, cathode is a negative terminal. Charges are getting repelled by the cathode and they are moving towards the anode. Okay, this shows that the particles which are moving towards the anode, they are called cathode. They are considered as a cathode rays, and that cathode rays are negatively charged, and they were known as electrons. Okay, they were called electrons. Okay, this is the discovery of electrons. Okay. This about the discovery of electrons. Electrons are the subatomic particles of atom. Thank you.